Alright, so I'm Michael from Castle High School, and this is my HSSEF 2022 project. So, from the beginning, we start with problem, that being that schools and scientists and other researchers lack a low-cost diver replacement ROV with the capability of not only bringing down a camera, but a payload of some sort, like a manipulator arm or sensor package. From this, I derived a number of specifications and constraints. It's important to note that there are a few off-the-shelf, open source, and DIY ROVs available. However, these don't meet all the criteria in one way or another. I then came up with two possible solutions, which I evaluated with a view chart. From this, I selected solution 2, which I then built. So, how does this thing work? Well, thrust is provided by 4 brushless motors in 3D printed housings. 2 of these thrusters are for vertical movement and 2 are for horizontal movement. Each of these thrusters is controlled by an ESC, or electronic speed controller. These draw power from an internal lithium battery. The ESCs receive signals through the tether from an RC receiver, which talks to an RC transmitter wirelessly. The camera system comprises of an internal FPV camera, which is also powered by the internal battery, which is controlled again through the tether connected to an FPV transmitter on the surface, which transmits a signal wirelessly to an FPV screen or goggles. These electronics on the ROV are housed inside a watertight enclosure, which is mounted to the frame. Depth and location varies depending on the objective of the test. For example, testing general capabilities, you'd want to do that in an enclosed environment like a pool, which is exactly what I did for the first test, which was a pool dive, just generally testing if everything worked and ballasting the vehicle. Then move on to open water tests. The second test was the first open water dive, which was just checking function and ballast in seawater. After some minor fixes, I moved on to the third and fourth tests, which were mainly assessing the vehicle's capability at depth. The third test had to be aborted early as the spot chosen for that dive had only sand on the seabed, making subsea navigation nearly impossible. So, moved on to the fourth test, which was at a different site with more geology and coral coverage on the bottom. However, this test did not quite go to plan. The rear vent plug was not put in, which caused a major leak. After some time, one of the main batteries and the internal camera both died. After the internal camera failed, I went to recover the vehicle by pulling on the tether. However, this inadvertently pulled out the rear end cap completely, flooding the inside of the enclosure. And after recovering the vehicle, it was discovered that despite being completely immersed in seawater for a brief period of time, all ESCs and one of the main batteries survived. The only things that failed were those 2 things mentioned earlier. After some repairs and minor improvements to the vehicle, namely the replacement of the internal camera and the attachment of a small dive light, moved on to the 5th test. This is meant to be a general evaluation of the vehicle before moving on to another depth test. However, some problems were identified, mainly that the rear penetrators still leaked. I had discovered this problem after the second test, but apparently all measures that I had taken to try and prevent this had failed. And the second problem was that the right horizontal thruster didn't respond properly. If throttle went above around 25%, that thruster would fail and cause the loss of control for a brief period of time. This, compounded with the fact that the internal camera began to fall off because it generated enough heat to melt the hot glue it was attached with, a deeper dive was deemed too risky, and thus testing concluded. All in all, tests were pretty successful. From these, identified a number of problems with the vehicles, some of which had been discussed earlier, the camera quality and penetrators and control problems. Some other problems were things like the difficulty of subsea navigation because we don't have any reference frame, and the frame. With this experience in mind, I then designed a second iteration. Some improvements would be some revisions to the frame to make the attachment of like a manipulator or something similar and a ballast much easier, and the addition of a basic instrument panel to make subsea navigation easier, and a simple leak detection system, among other things like a wireless buoy. Right, I believe that's it. Some sources, some image credits, other things, and that's it.